Hey everyone, this is Miss Moriarty, and I'm here to discuss with us the first two topics of Unit 9. Now, Unit 9 is all about global change. So, what you'll find as we go through this unit, a lot of topics that we've now discussed this year will resurface, and we're now going to kind of force connections and look at the big ideas and the big impacts of all the different ways in which we know humans use resources and the consequences of using those resources. Now, in topic 9.1, this is all about stratospheric ozone. So be very, very careful. Remember, back in Unit 7, we talked about what's called tropospheric ozone or ground level ozone. Now, it is still the same exact chemical formula as the ozone found in the stratosphere, which is O3. However, the ozone found in the stratosphere is the good ozone. That is the one that is important for life. That is the ozone that helps to block and absorb harmful UV radiation that may penetrate Earth's atmosphere and harm human health and other organisms. A decrease in any part of the ozone layer is going to increase chances of things like skin cancer or even cataracts in humans and other organisms, as well as have the potential to damage plant tissues. So be very, very careful. In 9.1, we are talking about now the depletion of the good ozone found in the stratosphere layer of our atmosphere. Now, how does stratospheric ozone form and naturally deplete itself? Well, ozone we know is comprised of three oxygen atoms, and while it remains in the stratosphere, it actually is continuously forming and breaking down. So we see oxygen gas or O2 continuously forming with free oxygen atoms, and that O3 is then breaking down or being split and reacting. Now, what actually helps to absorb the UV radiation are those reactions. So it is the photolysis or breaking of that O3 compound that winds up helping to absorb the harmful UV rays we were talking about, like UVC or UVB. Those actually split the O3 into O2 and a free oxygen atom. Now, looking at ozone depletion and human influence towards this. Anthropogenic ozone depletion is the result of what's called CFCs or chlorofluorocarbons. These were compounds that were commonly used as refrigerants or propellants in aerosol cans like hairspray or Febreze back in the 60s and the 70s. What is so harmful about CFCs is when they wind up being produced, they can actually persist in the atmosphere for very long periods of time. And because they contain elements such as chlorine, um, chlorine is a very highly electronegative atom, meaning that it really likes to pull electrons towards its nucleus. So when we wind up with the CFCs in the stratosphere, which contains ozone or O3, what it does is it actually strips away an oxygen atom from that O3, turning it into oxygen gas. Then that free oxygen atom can then bond to that chlorine, making chlorine monoxide, and then continuing to being lysed by the UV radiation, and then that chlorine atom can wind up breaking down more and more ozone, turning them into oxygen gas or free oxygen atoms. And so that's where we wind up with ozone depletion. Now, it's also a misconception when we talk about the ozone layer or the ozone hole. Remember, there isn't actually a hole in the ozone layer, there is simply just a thinning or less concentration of ozone. Where do we see the ozone thinning impact the most on Earth? Well, it's actually at the poles. And a part of the reason why is, especially at Antarctica, during springtime when the snow begins to melt. That water evaporates, right, rises up into the atmosphere. Now those clouds are going to consist of compounds like water, nitric acid, and potentially chlorine atoms from CFCs. Now, in this combination, we can call these polar stratospheric clouds. And in the presence of these polar stratospheric clouds, that nitric acid reacts with chlorine found in the atmosphere to make chlorine nitrate, and then hydrochloric acid reacts and continues to give off chlorine, producing more and more of those chlorine atoms that are going to wind up having the ability to strip the oxygen from the ozone found in the ozone layer. So we tend to see the thinning most likely occur actually at Antarctica or even in the North Pole as well. Now, what have we done to try and help the ozone layer? Um, well, we have eliminated the use of CFCs through what was called the Montreal Protocol that was established in 1987. After the establishment of the Montreal Protocol, we saw a tremendous reduction in the amount of CFCs being used in products. But remember, CFCs persist in the environment. So we do actually still see some remnants of them even today, even though that we have tried to eliminate them as best as we can. Now, instead of using CFCs, we have used an alternate called HFCs or hydrofluorocarbons as a replacement. But what we have found is compounds such as these are actually incredibly strong greenhouse gases. So they have the ability to absorb and trap a lot of heat, even greater than, say, carbon dioxide, carbon monoxide, or even methane. All right, everyone, that is it for our notes on 9.1 and 9.2. Be ready on Monday to discuss these topics.